Theoretical recap. A pre-commit hook is a script that Git executes automatically before finalizing a commit. It acts as a last line of defense gate. If the script exits with a non-zero code, the commit is rejected and the developer is forced to fix the problem before the code ever reaches the repository. This mechanism is part of the broader family of Git hooks stored in the hidden.git/hooks/ directory of every repository. The mental model is simple. Think of a pre-commit hook as a security guard standing at the entrance of your codebase. Every time someone tries to push new content in, the guard runs a checklist. If anything on the checklist fails, a hard-coded API key, a password in plain text, a forbidden file extension, the guard blocks the entry and explains why. A common mistake beginners make is confusing pre-commit hooks with C/CD pipeline checks. Hooks are local and client-side by default. They can be bypassed with git commit no verify. This is why hooks are a first barrier, not the only barrier. Another frequent error is writing a hook script without making it executable, chmod plus x, which silently renders it inactive. Mini example, a one-line hook that prevents committing any file containing the string password equals would look like this. Bash #!bin/sh. Git diff cached, grep I password equals an echo error, possible credential detected and exit 1. Exit 0. This is minimal but illustrates the core pattern. Scan staged content, raise an alert, exit with 1 to block. Workshop brief. In the previous chapter on secure branch policies, you explored the organizational and procedural side of protecting a Git repository. Now it is time to get your hands dirty and implement one of the most immediate technical defenses available to any developer, a pre-commit hook that detects potentially sensitive data before it ever enters version control history. You already simulated committing a secret and correcting it. You know how painful and risky that cleanup is. This workshop makes sure the problem is caught before it happens. Your goal is to create a working pre-commit hook in a local Git repository that automatically refuses any commit containing at least 2 types of sensitive patterns. The hook must be written as a shell script, bash or POSIX-sh, must be properly activated, and must produce a clear, human-readable error message when it blocks a commit. You will then demonstrate that it works correctly by staging intentionally dangerous content, attempting to commit it, and observing the block. Finally, you will verify that clean, safe content commits without obstruction. Step-by-step guidance. Start by initializing a fresh Git repository in your lab VM, the one you set up in the first workshop. Do not reuse a repository that already has sensitive history. Keep things clean. Navigate to the .git/hook/ directory and study the sample files already present. Understanding their naming convention and structure is your first task. Next, write your pre-commit script. The hook must detect at minimum 1. Any line matching a pattern suggestive of a hard-coded password or secret, for example, password equals, secret equals, API_key equals, token equals in a case-insensitive way, and 2. The presence of files with extensions commonly associated with sensitive data, for example, .pem, .key, .env. You decide how to implement this, using grep, awk, a loop over staged files, or a combination. The script must output a descriptive error message identifying which pattern triggered the block. Once the script is written, make it executable and test it rigorously. Create at least 3 test scenarios: 1 commit that must be blocked because of a credential pattern, 1 that must be blocked because of a sensitive file extension, and 1 clean commit that must go through without any issue. Document each scenario with the exact commands you ran and the output you observed. Screenshots or terminal copy-paste are both acceptable. As an optional but strongly recommended challenge, explore the pre-commit framework, https://precommit.com, and the Detect Secrets tool by Yelp. Try configuring one of these tools as an alternative or complement to your manual script. Compare the 2 approaches. What does a framework give you that a raw script does not? Note your observations in your submission. Finally, reflect briefly, 5 to 10 sentences, on the limits of this approach. Under what circumstances can a pre-commit hook be bypassed? What complementary mechanisms in a C/CD pipeline would compensate for those weaknesses? This reflection connects directly to what you will build later in the course when SAST and pipeline-level secret scanning are introduced. Submission and deadlines. You have 4 hours to complete this workshop. This includes reading time, implementation, testing, and writing your brief reflection. Submit your solution before the deadline expires. Your submission must include the full content of your pre-commit script, evidence of your 3 test scenarios, terminal output or screenshots, and your written reflection. Package everything in a single archive, zip or tar.gs, or a dedicated branch in your test repository, whichever format your instructor specified for submissions. You are fully authorized to consult all previous theoretical lessons from this course, reread the chapter on Git history and traceability, and use any internet resource you find useful. You may work alone or ask for help from peers, forums, or documentation. The goal is not to test memory but to assess your ability to translate concepts into a working, reasoned implementation.